All right, let's look at page 182 in your student workbooks at the lesson 7 practice problems. The temperature was recorded at several times during the day. Function T gives the temperature in degrees Fahrenheit. N hours since midnight. We notice that N time of day, N hours since midnight is our inputs, N degrees Fahrenheit is our outputs, or our y-axis. Here's the graph for the function. For each time interval, decide if the average rate of change is positive, negative, or 0. And so we're just going first from n equals 1 to 5. And so notice that there's like a 0 to 5 And so about how much is that little middle line? That's like 2.5. And so middle of that would be like 1.25. And so 1 is in between that. So from 1 to 5 would be kind of like from right here to 5. And what seems to be happening? Is it going up, going down from there to there? You got it. This one, I would say, is negative, going down. What about from 5 to 7? I'd say that's going up. You got it. What about from 10 to 20? Well, from 10, it starts here and is going up, going up, going up. But then at about, what does that look like? 15, 16, 17, 18, 19, 20. Somewhere around 17.5 or so, it starts going down. So I would say that this one goes positive and then negative. Finally, from 15 to 18, that's the positive part. And then from 20 to 24, that's definitely negative. How'd you do? The graph shows the total distance in feet walked by a person as a function of time. Was the person walking faster between 20 and 40 or between 80 and 100? So your answer is going to say either from 20 to 40 or either from 80 to 100 based on which one you think is steeper. Was the person walking faster between 0 and 40 seconds or between 40 and 100? So again, your answer is going to say either between 0 and 40 or between 40 and 100. When you get to one where you can't quite tell which one is going further, you may want to do some actual subtractions using the average rate of change formula, whatever you're comfortable with. So 0 and 40 or 40 and 100. You decide which one you think is going up the most. The height and feet of a squirrel running up and down a tree is a function of time in seconds. Here are some statements describing the squirrel's movement over 4 intervals of time and match each description. So this is one of those ones where you are going to match. So the average rate of change is negative. The squirrel runs up a tree very fast. The squirrel starts and ends at the same height. The squirrel runs down the tree. The squirrel runs up the tree slowly. So the negative is when the squirrel is going down the tree. So you're going to like draw a line from 1 to C, or you can write 1 or you can write C, however you want to match these. You're going to go do the same thing on the other 3. Which ones would match where? The percent of voters between age 18 and 29 that participated in the U.S. presidential election from 1988 to 2016 are shown below. Determine the average rate of change. So let's go remind ourselves of these formulas. So again, in middle school, we used y2 minus y1 over x2 minus x1, but we're now used to using the output of B, the output of A, that's the difference of those outputs over the difference of the inputs. Well, what's B and what's A? B would be the end number of the end of our interval, so 1992 and 2000. Sorry, I highlighted the wrong one. So let's go do 1992 and 2000. So we're looking at these ones. So starting with 2000 and subtracting the other end of our interval, and then finding the input for that output, and then you're going to go subtract those. So go plug those in and make a subtraction. So between 2000 and 1992, notice that we highlighted that interval, go y minus y over x minus x. You're going to want to subtract from the right to the left, from the right to the left. Pick two different values of t so that the function has a negative average rate of change between the two values. So since this top part is going up, we want to find when there's a drop in the bottom. And so, for example, from 35 to 42, that's going up. But from 42 to 33, there's a drop. You could use that little time frame. 33 to 34 goes up, 34 to 45 goes up, 45 to 48. Oh, here's another drop. You could use these two intervals and then the next one. So you have two options here for where there's a little drop to use that interval and to try part B. Pick two values that it has a positive average rate of change. So all these other options besides the two drops could be used as a positive rate of change. You could even go from 35 all the way to 34. You could literally do the whole jump, use the whole table, the whole interview, because that has a positive average rate of change over time. Okay, and by the way, you're using still the same formula from A on parts B and C to do that calculation. Jada walks to school. The function D gives her distance from school in meters as a function of time. What does D of 10 equals 0 represent? So one of these is the time in minutes, and one of these is the distance. What do you think? Well, if her distance from home is 0, it means after 10 minutes she is back home. Jada walks to school. The function D gives her distance from school in meters and T in minutes since she left home, which equation tells us that Jada is 600 meters from school after 5 minutes. Take a minute to select your answer. How'd you do? Did you get it? Finally, a new website shows a scatter plot with a positive relationship between the number of vending machines in the school and a percentage of students who are absent from school on average. The headline reads, "Vending machines are causing your youth to miss school." So what's wrong with this claim is there is no correlation or relationship between the number of vending machines and absences. What's a better headline for this information? If there's a positive relationship between the number of vending machines in the school and the percentage of students who are absent from school on average, I mean, literally there's no relationship. So whatever you want to write here, a better headline could be just because we have vending machines, we're still having a lot of absences. So having vending machines on campus is not getting our kids to come to school. How else can we get our kids to come to school? Something like that. Okay, how'd you do?